Are you guys able to hear me? Am I audible clearly? Am I audible? Board is clear? Yes? Okay. Let's begin with the numericals. In the last class, we had seen properties. We had seen some one or two numericals also, how to apply the properties. So we'll move ahead. The next question is asking us the number of distinct roots, that also real roots. The number of distinct real roots for this determinant sin x, cos x, cos x, cos x, sin x, sin x. This is also cos x. This is also cos x. This is also cos x equal to 0. The number of distinct real roots for this particular determinant equals to 0 in the interval x is greater than or equals to minus pi by 4 and less than or equals to plus pi by 4 is option A is 0, option B is 2, option C is 1 and option D is 3. Can you guys try? We have to apply the property. Okay, don't directly solve the determinant, otherwise it will become very difficult. If I take directly the determinant, I'll get lot of terms over there and everywhere applying sin and cos, and then okay, simplifying it will take a lot of time and it will become a difficult one. So it's better in all the determinant numericals. Okay, any given determinant numericals, any type of determinant questions when they are asked, our focus should be on somehow getting ones and zeros. Okay, somehow getting ones and zeros, that should be our focus. So that, okay, if we are getting 1 and 0, then finding determinant becomes easy and then solving them also becomes very easy. Okay, so any given numerical of determinant, okay, remember this tricks. Okay, we'll try to get ones in some row or one in the column. Okay, and then that if we are getting one, then we'll try to make two ones zeros, and in that we'll see pursuit what happens. So the things becomes very simple. Okay, so let's try it. Okay, so I can do row transformations also and column transformations also. I can do this thing also, R2 minus R1. So, sorry, R2 minus R3. So that I can get cos minus cos is 0. But then I will get this 0. And this will get converted into some other terms. Because I have only 3 sin and lot of cos. Or I can try see, if I'm adding column 1 and 2, if I'm adding column 1 and 2, sorry, 2 and 3 to column 1, so then it will become sin x plus cos x plus cos x, that is sin x plus 2 cos x. Here also, I'll get cos x plus sin x plus cos x, so here also it will become sin x plus 2 cos x. Here also, if I add column 2 and 3, so it will become cos x plus sin x, that is sin x plus 2 cos x. So then I can remove that common, whatever will remain inside is 1. Okay, so I said the first focus in any numerical, not only in this numerical, okay, for the determinant, we should try to get ones and then try to make them 0. It will become easy. You can try this. You can try another method after this class. Okay, there is a reason why I am saying it. Those who are not agreeing with my logic, don't worry. You can try this numerical, same numerical by doing some rows and column transformation and try to find out the answer. Okay, you will understand which method becomes much more easier. Okay, so let's do it. So I am going to do by this method. So what I'm going to do is I'm going to add C2 and C3 in my column C1. So the transformation is occurring only in column C1. Therefore, C2 and C3 will remain as it is. So I can write it as cos x, sin x, cos x, cos x, cos x, sin x. And this will become sin x plus 2 cos x. Here also I'll get sin x plus 2 cos x. And here also I'll get sin x plus 2 cos x equal to 0. He has given us, so I'll get equal to 0. Okay, and then now this row is exactly same, so I can remove this element. So sin x plus 2 cos x, I'll take common. So now what will remain inside is 1, 1, 1 over here. And here cos x, sin x, cos x, cos x, cos x, sin x equals to 0. Now we'll try to make both of this as 0. Okay, we'll try to make both of this as 0. So R2 minus R1 and R3 minus R1. So the transformation is occurring in R2 and R3 only. Okay, the transformation is occurring in R2 and R3 only. So R1 will remain as it is. So therefore sin x plus 2 cos x. First row will remain as it is 1 cos x, cos x. This determinant equals to 0, he has given us. So 1 minus 1, that will become 0. Sin x minus cos x, so this will become sin x minus cos x. This cos x minus cos x, so this will become 0. Similarly, 1 minus 1, this will become 0. Cos x minus cos x, so this will also become 0. This sin x minus cos x. So this will give me sin x minus cos x. So now I have got enough numbers of ones and zeros. So now I can try to expand it. So I'll get sin x plus 2 cos x, and I'll take the determinant of this. It will be 1 into this into this minus this into this. So sin x minus cos x, sin x minus cos x. So this will become sin x minus cos x, the whole square minus 0. Then minus cos x into this into 0 minus 0 into 0. So this will be 0 plus cos x into 0 into 0 minus 0 into this. So this will also be 0. And this the whole determinant is equal to 0. It is given to us. So now I will get this is also 0, this is also 0. So I am getting sin x plus 2 cos x into sin x minus cos x, the whole square is equal to 0. Because these two are already become 0 and this is in multiplication. So now I can write therefore sin x plus 2 cos x is equal to 0, or sin x minus cos x, the whole square is equal to 0. And I can write this goes over there, therefore I can write sin x minus 2 cos x sin x is equals to minus 2 cos x, and here I can write or sin x minus cos x equals to 0. So from here I'll take this cos x over here, so I'll get tan of x is equals to minus 2, or from here I'll get sin x is equals to, this goes over there, so this will become sin x is equals to cos x. So I'll get tan of x is equals to minus 2, or I'll get this will come over here. So from here I'll get tan of x is equals to 1. Now we know that, okay, tan of 45 is 1, so tan gets cancelled, and from here I get the value of x is equal to pi by 4. Now we don't have direct value for tan of 2. We have, okay, tan of 0 is 0, tan of 30 degree is 1 by root 3, then tan of 45 degree is 1. And then directly we have root 3, right? And then we directly have infinity. So tan of 60 degree gives us root 3, which is less than 2, whereas tan of 90 degree gives us infinity. Therefore, this x lies between 60 degree to 90 degree, and that also it is minus. So my x is nothing but it is going to lie between minus pi by 3 to minus pi by 2. Yes or no? Because the answer 2 will come somewhere between root 3 and infinity. So somewhere between root 3 and infinity, we are going to get, okay, the value 2. So x belongs to this. So here I have got this one value is pi by 4, but it is saying us to limit between the interval minus pi by 4 to plus pi by 4. Now this values are, but obviously my value is less than minus pi by 4. It's telling us my x should be greater than minus pi by 4. But minus 60 degree, minus 90 degree will be lesser than minus 45 degree. Okay, hence, how many solutions are there? You are going to have only one solution in the given domain, and that is also x is equal to pi by 4. So our answer is this. Okay, the number of distinct real solutions for the given question is this one. This is come in the year 2001. Okay, this question has come in the year 2001. Is it clear? Everyone has understood? After the lecture, you can try by the other method also. Okay, you can also try to make initially this 0 and do some columns and rows transformation. Then you will understand the advantage of this method, getting 1, 1 and 1. Okay, please take the screenshot of done. Okay, everyone, please take the screenshot before I rub it. So now the offline classes are also started. So maybe from next week, okay, we all will be there offline over there, so that we can do it much better. Okay. So I hope everyone has taken the screenshot. Next question. This is come in 2017 mains. Let omega be a complex number such that omega is a complex number such that 2 omega plus 1 is equal to z. Okay, omega is a complex number such that 2 omega plus 1 is equal to z, where z is equal to under root of minus 3. If 1 1 1 1 1 minus omega square minus 1 omega square omega raised to 7 is equals to 3k. Then the value of k is then the value of k is option A, k is equals to minus z. Option B, k is equals to z. Option C, k is equals to minus 1. And option D, k is equals to 1. So this has come in the year 2017. I hope you guys remember a little bit of complex numbers. Remember one thing, okay, in your JEE exams, the chapters will always remain interconnected. You will observe that, okay, here now one complex number numerical has come. There will also be numericals where we will have to use derivatives and integration. Okay, and that I will keep for the later questions where I will start with the calculus. You will always see that interconnected chapter questions are going to come. It's not that it will remain only on one concept. Okay, it will combine the concepts of one or two chapters and then it will make a question. Here also it's similar kind of a thing only. The major portion will be of determinant, but still we do require knowledge of complex numbers to solve this numerical. We'll have similar lot of questions coming up, okay, where we will require certain knowledge of relations and functions. Okay, we will require certain knowledge of calculus, then only we'll be able to solve certain numericals. So I hope you guys remember complex numbers, you have not forgotten. So z is under root of 3i, so z can be written as under root of minus 1 into under root of 3. And under root of minus 1 is nothing but I, so this will become root 3i. Okay, the value of z becomes root 3i. Next, from here I can find out the value of omega as 2 omega is equals to z minus 1. Therefore, omega is equals to z minus 1 upon 2. The value of z is root 3i, so that will become root 3i minus 1 upon 2. So which can also be written as, therefore omega is equals to minus 1 plus root 3i upon 2. And from the complex numbers we know that omega square is nothing but is complex conjugate of omega. So in complex conjugate you only change the sign of the imaginary part. So it will be minus 1 minus root 3i upon 2. Okay, now I have written this because we are having that term over there, omega square. So somewhere at the end, okay, before getting the relation, we will have to substitute the value of omega square. So omega square is nothing but complex conjugate of omega, and in complex conjugate, okay, we just change the sign of the complex number or the complex part. Moreover, we should also know this 1 plus omega square plus omega is equal to 0. You have this relation also in the complex roots of the complex number topic. You must have seen this 1 plus omega square plus omega equals to 0. So it will directly help us over here. So I have this term over there minus omega square minus 1. So if this goes over there, so I'll get omega is equals to minus omega square minus 1. Now instead of this term minus omega square minus, I can put omega over there. But we are seeing one more term over there, and that term is omega raised to 7. Okay, we are seeing one more term over there, which is omega raised to 7. So we'll have to find out the value for that also. So if you guys just remember, complex cube of omega is 1, so therefore I can write it as omega raised to 7 can be written as omega cube into omega cube into omega. So omega cube is 1, so this will become 1 into 1 into omega. So therefore, omega raised to 7 is going to give me the value omega. You must have studied formula also, omega raised to 3 plus k, where k is equal to 0, 1, 2. It is cyclic form we get the values. So you must have studied. I am not showing this formula because it is not required in this question. What we required is only up till omega raised to 7. So that is what I am showing logically. Okay. In complex number, omega is the complex cube root of unity. And therefore, I can write something like this. Omega cube will be 1. Here also omega cube will be 1. So 1 into 1 into omega, that is omega. So I get omega raised to 7 as omega. So now over there, everything I'll get in terms of omega or omega square. Okay, so our numerical will now become easy. So I'll get this 1, 1, 1, 1, 1. Now instead of minus omega square minus 1, I can write this. I can write omega. Here I have this omega square. Here also I have this omega square. And omega raised to 7 can be written as omega. Instead of omega raised to 7, I have written omega. And he's saying it is equal to 3k. Now if you want, you can make these two terms as 0. Otherwise, you already have 1, 1, lot of 1, 1s are there. We can directly take determinant. It will not give us much complex value. So I'm directly taking determinant 1 into omega, that will become omega square minus omega square into omega square, that will be omega raised to 4. Minus 1 into omega into 1, that is omega, minus 1 into omega, that will be omega square. Plus 1 into omega square into 1, so that will be omega square, minus 1 into omega, that will be omega, is equals to 3k. Omega raised to 4. So omega raised to 4 will also be omega, which can be written as omega cube into omega. Omega cube is 1. Therefore, omega raised to 4 can also be written as omega. So I get this omega square minus omega. This can be written as omega. This will become minus omega, minus this will become plus omega square. And this will also be omega square minus omega is equal to 3k. So omega square plus omega square plus omega square, that will be 3 omega square minus omega minus omega minus omega minus 3 omega. So I'll get 3 omega square minus 3 omega is equal to 3k. 3 I can take common and I can cancel it out. Therefore I'll get omega square minus omega is equal to k. So I have to find out the value of k, and that is also in the terms of z or some number. So that is why now I will substitute the values over here. So therefore I can write k is equal to omega square. Omega square is nothing but complex conjugate, that is omega bar minus omega. Therefore I'll get k is equal to value of omega bar is minus 1 minus root 3I upon 2 minus the value of omega is minus 1 plus root 3I upon 2. Therefore I'll get the denominator is same. So minus 1 minus root 3I minus plus 1 minus that will be minus root 3I. So plus 1 minus 1 gets cancelled. So I'll get k is equals to minus root 3I. So that will become minus 2 root 3I upon 2. So 2 gets cancelled. So I'll get k is equals to minus of root 3I. And our z is nothing but root 3I. So instead of root 3I, I can put z and I'll get k is equals to minus z. Therefore, our answer is option number A. Okay, we had to find out the value of the k which is satisfying the given determinant, and we have successfully found out the value to be minus z. Clear? So you must have understood such type of question will always come where the concepts of the chapters are interlinked. So every chapter is important. Please take the screenshot, everyone. Everyone. Okay, everyone has understood? Taken the screenshot? Okay then. Let's go to next type of numericals. Let's see next. If f of x is equals to 1, 2x, 3x into x minus 1, x, x into x minus 1, x into x minus 1 into x minus 2, x plus 1 into x plus 1 into x plus 1 into x minus 1. If f of x is equal to determinant of this, then the value of f of 100 is option number A 1, option number B 0, option number C 100, and option number D minus 100. You can just give it a try. Just try to find out the value of the determinant. If we find out the value of determinant, we'll get the value of f of x. Once we get the value of f of x, we can get the value of f of 100 also. But again, don't directly try to solve it. First think how we can try to get ones over there or zeros over there, so that when we do the determinant, it becomes easy. Just give it a little bit try. So if I see here, this column is having, in all the columns I have x over here, in all the columns I have x plus 1 over here. So I can take them outside, I can take them common. So I get here x into x plus 1. So I get f of x is equals to x into x plus 1 into determinant of 1, 2x, 3x into x minus 1. Here what will remain is 1, x minus 1, and here x minus 2. Sorry, x minus 2 into x minus 1. Here what will remain is 1, x, and here x into x minus 1. So now due to taking common something like this, I've got 1, 1, 1. I'll try to make them 0. Okay, what I'll do is I'll try to make them 0. So I can do C2 minus C1, and I can do C3 minus C1. I'll get x into x plus 1. So the transformation is occurring in C2 and the transformation is occurring in C3. So C1 will remain as it is, 1, 2x, 3x into x minus 1. So I am doing C2 minus C1. So 1 minus 1, that will be 0. X minus 1 minus 2x. So that will become x minus 1 minus 2x. So that will give me minus 1 minus x, and then here it will give me, I'll have to solve this completely. Let me just rethink, otherwise it will make life complex for us. Or instead, this 2x minus x, and here I have x into x minus 1, here I have 3x into x minus 1. So instead, let me do this. C1 minus C3. Okay, let me instead try this, C1 minus C3. So the transformation is occurring in C3. So C2 and C3 will be common. So x1, x minus 1, x minus 2 into x minus 1. This is 1, x, x into x minus 1. Now when I subtract 1 minus 1, that will become 0. 2x minus x, so that will give me x. And then 3 into x minus 1, so this will give me 2 into x into x minus 1. So here I have got 0. Then I can try with this 2 also. So here also when I subtract 1 minus 1, so this will become x minus 1 minus x. So this will also be even better thing. So I can do in this step itself, I can do C2 minus C3. Okay, so if I do C2 minus C3, so 1 minus 1, that will give me 0. X minus 1 minus x, so that will give me minus 1. And over here, x minus 2 into x minus 1 minus x into x minus 1. So x minus 1 I can take common. So what will remain inside is x minus 2 minus x. So here also plus x minus x gets cancelled. So here I'll get minus 2 into x minus 1. Okay, so here I'll get minus 2 into x minus 1. So now here also I have x minus 1. Here also I have x minus 1. Here also I have x minus 1. So that I can take common. So I'll get x into x plus 1 into x minus 1. So that will become 0, 0, 1, x minus 1, x 2x minus 2x. Okay, so now I can try to take the determinant. Now the things have become very simple. So now I'll take the determinant. So I'll get f of x is equal to x into x plus 1 into x minus 1 into, let me take the determinant. 0 into anything is going to give me 0, minus this 0 into anything is again going to give me 0, plus 1 into. So when I take determinant, I have to cancel this row and this column. So minus 2 into x, so that will be minus 2x minus. So now this minus minus will become plus. So here I'll get plus 2x. So I'm getting f of x is equal to x into x plus 1 into x minus 1 into plus 2x minus 2x gets cancelled. 1 into 0 is 0. So 0 plus minus 0 is going to give me 0 only. So I'm getting f of x is equal to 0. So this implies that my f of 100 also will be 0. So my answer is option number B. Okay, my answer is option number B. This has come in the year 2000. Okay, this has come in the year 2000 in IIT. Everyone please take the screenshot of this. Everyone has understood? Okay, we have to think like just before that I tried some other operations and I saw that I'll get some complex things, and that is why I just changed the operation and I got it easy. So the very first work in any numerical, I said you should always try to get 1 and then try to make it 0 and then solve the determinant. So life will become very easy if you do that. Everyone has taken the screenshot? Yes? Okay. So today we have 2.5 hour lecture. So in between we'll take some 5-minute break. I'll not end the meeting. We'll remain in the meeting only, but we'll take a break of 5 minutes as the lecture is of 2.5 hours. And I'll get exhausted in exact 2.5 hours. So after some half an hour, we'll take a break of some 5 minutes. Okay, the meeting will remain on only, will not end the call, will remain in the meeting, but we'll take a break of say 5 minutes. Okay. Let's try next numerical. The parameter on which the value of the determinant on which the value of determinant. So this given determinant is 1 cos p minus dx sin p minus dx a cos px sin px a square cos p plus dx sin of p plus dx. The parameter on which the value of this given determinant does not depend upon is option A is C, option B is D, option C is A, and option D is X. So on which parameter does the determinant of the given question is independent, which means we will have to solve this entire determinant, and once we get the value of determinant, either of the things should be missing. Either the final answer of the determinant should not consist of A, or it should not consist of P, or it should not consist of D, or it should not consist of X. Then only we can say that the parameter on which the value of this given determinant does not depend is fluency. So first we will have to solve this determinant. Okay, we'll have to solve this determinant, and then only we can get, okay, which is the answer. Can you guys little bit give a try? Just give it a try. See that the terms are P minus D, and there the term is P plus D. You also have to think about that terms also. Because if you are not able to get it into the simple form, okay, then will not be able to simplify it. So you have to think about that terms also. What can I do? I can add. What does cos A plus cos B? Do you remember all these formulas? Do you remember all these formulae? Yes? Okay, if not, then don't worry. When I come over there, you tell me, I'll give you a very, very simple trick to remember, okay, all the compound angle formulas, sum and different formulas, sum into product, product into sum. I'll give you very simple tricks. As of now, let's try this. So, C plus C will give me 2CC, and S plus S will give me 2SC. Okay, this is the trick which I follow. Okay, if you are able to remember, then it's good. If you are not able to remember, don't worry. We are going to start offline, so when I come there, I'll give you the trick. So first, my aim is to remove this angle. Okay, so I'm going to add this column, this column, and this column. So I'm going to do C1 plus C2. So the transformation is occurring only in C1. So C2 and C3 as it is. So 1 plus A square, this will become cos of P minus dx plus cos of P plus dx, and this will be sine of P minus dx plus sine of P plus dx. Column 2 and column 3 will remain as it is. Sorry, I am adding third column. Column C1 plus C3. So this will be A cos Px sin Px A square cos of P plus D x sin of P plus dx. Okay, so that gives me 2C plus P. See, that is, we add this and then we subtract. So P minus D plus P plus D upon 2. So that will give me D will get cancelled, 2P upon P. So this is going to give me P. Similarly, P minus D minus P plus D. So that will be P minus D. So here PP will get cancelled, and it is going to give me minus D. Okay, so this will become 1 plus A square this will give me cos of P minus D. So this will give me 2 times cos of Px into cos of minus dx. This will also give me 2 times sine of Px into cos of minus dx. Okay, and this will remain as it is. A cos Px sin Px A square cos of P plus D into x sine of p plus b into x. So cos of minus theta is cos theta. Okay, cos of minus theta is cos theta, and therefore I'm removing this minus. Okay, I'm getting cos of minus dx when I'm subtracting the angles. Cos of minus theta is cos theta, so I'm just writing it as cos dx, and here also I'm writing it as cos dx. Okay, so somehow I've got rid little bit of that. Now let's see next what to do. Uh, Cos px cos dx. So if I do this, yes, I'll be able to cancel it out. So now what I'm going to do is, okay, what I'm going to do is this. I'm going to do C1 minus 2 cos dx into C2. So I'm going to multiply the entire second column with cos dx and 2, because same terms are there over here. If I multiply here with 2 cos dx, so I'll get same term, 2 cos px into cos dx. Here also when I multiply it with cos dx, I'm going to get the same term, 2 sin px into cos dx. And then I can subtract it to get here zeros. Okay, so that is why I'm writing C1 minus 2 cos dx, okay, into C2. So the transformation is occurring only in C1. So C2 and C3 will remain as it is. So A cos px sin px a square cos of p plus dx sin of p plus dx. Okay, so when I subtract, this will become 0 and this will also become 0. So this 2 will become 0. And the first term I have over there as 1 plus a square minus 2 into cos dx, and here I have this a. So this will become 1 plus a square minus 2a cos dx. But this 2 became 0. Okay. So now even if I am having two zeros, I can take the determinant. So 1 plus a square minus 2 cos dx into, I am taking determinant. So this into this. So that will become cos px into sin of p plus dx minus sin px into cos of p plus d into x. Then a into 0 is 0, this into 0 is 0. Similarly, a square into this into 0 is 0, this into 0 is 0. So all this comes and going to get 0. Okay. So if I see, if I name it as A and B, so this will be my B and A. So we have this formula sin A cos B minus cos A sin B is nothing but expansion of our sin of A minus B. Right? So this will be my expansion of, so I'll get here 1 plus A square minus 2A cos dx into, this will become an expansion of sin of A minus B. Here my A is P plus D minus B is P x. I'm getting determinant is equal to, so determinant is equal to 1 plus A square minus 2A cos dx plus P minus P gets cancelled. So I get sin of dx. So I'll get determinant is equals to 2 sin into cos is So I'll get 1 plus a square minus a into sine 2 dx. Okay. So now which terms you can find over here? You can find out. You can see there is a, there is b, and there is x, but there is no p. Therefore, our answer becomes the parameter to which the determinant value does not depend is this p. Because when we find out the answer to the determinant, there is no p term over there. There is a, there is d, and there is x, but there is no p term over there. And therefore, we can say that the parameter on which the value of this given determinant does not depend is p. Is that clear? Everyone, is that clear? Okay, so please take the screenshot of this, and we are going to take a break of 5 to 7 minutes. Okay, we are going to take the break of 5 to 7 minutes. So for that time period, I'm just switching off the video. Will remain in the meeting itself. Again, after 5 to 7 minutes, I'll start with the next numerical. Okay. I'm just taking a break of 5 to 7 minutes. Am I audible, everyone? Let's restart the session. Okay. Just a minute. Okay, let's see next numerical. Which of the following values of alpha satisfy the equation? Is asking which of the values of alpha satisfy the equation. An equation is giving us in the determinant form 1 plus alpha square 1 plus 2 alpha square 1 plus 3 alpha square 2 plus alpha square 3 plus alpha square 2 plus 2 alpha square 3 plus 2 alpha square 2 plus 3 alpha the whole square 3 plus 3 alpha the whole square is equals to minus 648 alpha. Which of the following values of alpha satisfy this determinant equation? Okay, and the values are A is equals to minus 4, B is equals to 9, C is equals to minus 9, D is equals to plus 4. This has come in Advanced 2015. This has come in JEE Advanced. So when we talk about advanced, multiple options can be right. Remember that. For most of the advanced questions where the options are there multiple options may be right. So here when I solve this equation or when I solve this determinant, I can get multiple values of alpha. So let's try it. Okay, I cannot directly now add or subtract the columns. First I will have to simplify them. Then only I can add or subtract to columns or to rows. So this will become 1 plus 2 alpha plus alpha square, 4 plus 4 alpha plus alpha square, 9 plus 2 into 3, 6. So 6 alpha plus alpha square, 1 plus 2 into 2, that is 4 alpha plus 4 alpha square. This is 4 plus 2 into 2, 4 into 2, 8. 8 alpha plus 4 alpha square. Then 9 plus 3 into 2, 6 into 2, 12. So 12 alpha plus 4 alpha square. Then this will be 1 plus 2 into 3, so that is 6 alpha plus 9 alpha square. This is 4 plus 2 into 3, 6 into 2, 12 alpha plus 9 alpha square. Then 9 plus 3 into 3, 9 into 2, 18 alpha plus 9 alpha square. Now, yes, we have seen one property also. We had seen one property that we can write the determinant as sum of two or more elements. So I can try that if I'm getting. Let's see. I can three determinants because all the terms are expressed in terms of three determinants. Okay, so I can write it as 149 and here also 149 and here also 149. Look, the next determinant may consist of then 2 alpha, 4 alpha, 6 alpha, and from here 4 alpha, 8 alpha, 12 alpha, and from here 6 alpha, 12 alpha, 18 alpha. Plus, I can write alpha square, alpha square, alpha square. Here also 4 alpha square, 4 alpha square, 4 alpha square. And here 9 alpha square, 9 alpha square, 9 alpha square. So now if two rows or columns are common, then the determinant is 0. So this will give me determinant as 0. Now if I take alpha square common from here and 4 alpha square common from here, then here also I'll get 1, 1, 1, here also I'll get 1, 1, 1. If two rows or two columns of a determinant are same, then the determinant is 0. This will also give me answer 0. Suppose if I see here, if I take alpha common, and then suppose if I take 2 common from here, then I'll get 1, 2 and 3. Suppose I take 4 common from here, then here also I'll get 1, 2 and 3 only. And this will also give me determinant 0. Then I'll get minus 648 alpha is equal to 0, which means I will get a trivial solution. Okay, I will get a trivial solution, so I cannot solve like this. I will have to think of some other way. Okay, you just saw if I'm doing like this, I'm getting this, this and this 0, which means I'll get minus 648 alpha is equal to 0, which means I'll get alpha is equal to 0, and that option is not there over here. Which means I will have to think of some other method. So let's think about that. Can I write it as multiplication of two matrices instead of addition of two determinants? Can I show it as multiplication of two determinants? So let's try that. We do go into column, right? So multiply first, go into first column, first go into second column. So let me take here as 1, 1 and 1. Then it will make my life easy. Okay, if I'm taking 1, 1 and 1, it will make my life easy. So if I want this term, then I want 1 over here. I want 2 alpha over here and I want alpha square over here. So 1 into 1 is 1 plus 1 into 2 alpha is 2 alpha plus 1 into alpha square is alpha square. So I'll get this one. Then first go into second column. So 1 into 1 will give me 1. Here I need 4 alpha, so I'll write 4 alpha over here. I need 4 alpha square, so I'll write 4 alpha square over here. Okay. So then I'll get first go into second column. So 1 into 1 is 1 plus 4 into alpha is 4 alpha plus 1 into 4 alpha square is 4 alpha square. When I do first then go into third column, so I need 1 over here and then I need over here 6 alpha and 9 alpha square. So I'll get 1 into 1 is 1 plus 6 alpha into 1 is 6 alpha plus 9 alpha square into 1 is this. So So I have got this first two into first column, first two into second column, first two into third column. Okay. Similarly, I can find out here also. So I need 4 over here, so I'll write 4. Then I need 2 alpha is there over here. I need 4 alpha, so I'll just write 2 over here. So 2 into 2 alpha, that will give me 4 alpha. Then alpha square, here it is alpha square. So I'll write here 1. So now if I do 4 into 1 is 4, plus 2 into 2 alpha is 4 alpha, plus 1 into alpha square is alpha square. So other terms also I get only. So similarly, if I need first over here, I need 9. So 9 ones are, that will give me 9. 6 alpha, I have 2 over here. So 3 into 2, that will give me 6, because here I already have alpha square. Here I already have alpha square. So I need 1. So now when I do 9 into 1 is 9. 2 into 3 is 6 alpha, and 1 into alpha square is alpha. So now I've got the two matrices of which this given matrices is the product of. Sorry, given determinant is the product of. Okay, so I can write it as 1, 1, 1, 4, 2, 1, 9, 3, 1, and from here, from this entire row I can take alpha as common, and from this entire row I can take alpha square as common. So alpha into alpha square is going to give me alpha cube, so I'll get alpha cube over here. And what will remain inside is 1, 1, 1, 2, 4, 6, 1, 4, 9 is equals to, is given as minus 6, 48 alpha. So 1 alpha will get cancelled out. We'll find out the determinant of this. We'll find out determinant of this. We'll find out determinant of this, and we'll multiply it with the alpha cube. Okay. Already 1, 1, 1s I have, so I may get a simplified form only. So 1 into 2, that is 2, minus 3 into 1, that is 3, minus 1 into 4, that is 4, minus 9 into 1, that is minus 9. Then plus 1 into determinant of this will give me 4 into 3, that is 12, minus 9 into 2, that is minus 18. This is determinant of this. Then we have into alpha cube, and then we have this. We can find out determinant of this. So 1 into 9 into 4, that is 36, minus 6 into 4, that is 24, minus this 1 into 9 into 2, that is 18, minus 1 into 6, that is 6, plus this 1 into 4 into 2, that is 8, minus 4 into 1, that is 4, is equals to minus 648 alpha. So 2 minus 3 is minus 1 into 1, minus 1. 4 minus 9 is minus 5 into minus 1, so that will give me plus 5. 12 minus 18, so that is minus 6 into alpha cube into. This is going to give me 36 minus 24, that is 12, minus 18 minus 6, that will also give me 12, plus 8 minus 4, that is going to give me 4, is equal to minus 648 alpha. 1 alpha will get cancelled, so I'll get here alpha square. So 5 minus 6 minus 1 minus 1, that will give me minus 2 into alpha square. 12 minus 12, and here I'll get 4, is equal to minus 648. Minus sign gets cancelled, so I'll get alpha square is equals to 648 upon 2 into 4. So 4 16s are, 4 2s are, 2 1s are, 2 81s are. So I'll get alpha is equals to square root of 81. Therefore I'll get alpha is equals to plus minus 9. So I'm going to get two values of alpha. Okay, one is plus 9 and one is minus 9. Therefore, the answer is this, option B and option C. Okay, therefore the answer is this, option B and option C. He told us to find out the value of alpha, which this particular equation satisfied. So we have solved and we got the values of alpha are plus minus 9. Take this screenshot, everyone. Okay, I hope everyone has taken the screenshot and everyone has understood. Okay, then. Let's try next numerical. Find positive numbers x, y and z for the positive numbers x, y and z, the numerical value of the determinant. So the value of this determinant 1 log of y to the base x log of z to the base x log of x to the base y 1 log of z to the base y log of x to the base z log of y to the base z and 1 is. Okay, we have to find out what will be the value of this determinant. So let's try. So first, let us write them into the natural logs. So I'll get 1. This can be written as log y upon log x, log y to the base e upon log x to the base e. Similarly, by using log property, this can also be written as log z to the base e upon log x to the base e. Similarly, this can also be written as log x to the base e upon log y to the base e. Similarly, this is 1 and this can be written as log z to the base e upon log of y to the base e. Same over here, log of x to the base e upon log of z to the base e. Same over here, log of y to the base e upon log of z to the base e, and this is 1. So now what I can do is, from this row I can take log x is common. From here I can take 1 by log y common, and from here I can take 1 by log z common. So when I do that, and I am taking 1 by log x common, then from here I am taking 1 by log of y common. From here I am taking 1 upon log of z is common. So what will remain here is, here I will get log x because log x was not there over here. Log of y. Here what will remain is log of z. Similarly, from here I have taken log y common, so here what will remain is log x. Here it was 1, so here it will become log of y, and here what will remain is log of z. Then from here I have taken 1 by log z is common, so what will remain is log x. Here what will remain is log y, and here what will remain is log z. Now this entire column is same, and here also this entire column is same. So I can take from this column, I can take log s is common, and from this column, I can take log y as common. So I'll get log x upon log x into log y upon log y because I've taken common into 1 upon log z. Here I'll get 1, 1, 1. Here also I'll get 1, 1, 1. And here I'll get log z, and log z. So determinant of this. So we have seen the property if any two rows or columns of a determinant is same, then the value of determinant is 0. So the value of these two columns is same or identical, hence the value of this determinant is 0. He told us to find out the value of this given determinant. Okay, and we have got the value of this determinant as 0. Okay, please take this screenshot. Everyone, please take this screenshot. Okay, I hope everyone has taken this screenshot. Let's go to next numerical. So we have to find out the value of determinant 1, 1, 1, A, B, C, A square minus BC, B square minus CA, and C square minus AB is. What is the value of this determinant? So let us try to find out the value of this determinant. So I can express if the property, if you remember, if any terms of row or column are expressed as sum of two numbers, then the determinant can be shown by sum of two determinants. So that is what I'm going to do over here is, so 1, 1, 1, A, B, C, and here I have A square, B square, C square. The next determinant, since here I have minus, 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 therefore instead of plus, I am writing minus over here. So here I'll get 1, 1, 1, A, B, C, and here B, C, C, A, A, B. Okay, this minus I have already taken over here. So let's try to find out the value. So what I am going to do over in this case is, I'll try to find out this determinant in terms of this. Okay, because the two columns are exactly same. So if I somehow try to get the third column also in the similar fashion, then I'll be able to find out. So I'm taking only this this determinant. Okay. Over here I'm only taking this determinant and I'm solving only that determinant 1, 1, 1, A, B, C, B, C, C, A, A, B. So now if I multiply this entire row with A, so here I'll get ABC. If I multiply this with B, then I'll get here ABC. If I multiply here with C, then I'll get here ABC, and here I'll get A square, B square, and here I'll get C square. So what I'm going to do is, I'm going to do this. I'm solving only this determinant So I'm going to do, I'm going to multiply row 1 with A. I'm going to multiply row 2 with B, and I'm going to multiply row 3 with C. When I do that, I'll get over here A, here I'll get A square, and here I'll get ABC. Similarly, when I multiply with B, I'll get B, I'll get B square, and here also I'll get ABC. Here I'll get C square, and here also I'll get ABC. So I can take this ABC as common. When I take ABC as common, so I'll get here as A, B, C, A square, B square, C square, 1, 1, and 1. Now if you see, this and this are exactly same terms, only the columns and rows are not same. Sorry, columns are not same, so we can interchange the column. And if we interchange the column, then the value of the determinant, okay, the sign of the determinant changes. So don't worry, we'll do that. First, I need over here 1, 1, 1, so I'll swap, okay, this with this. So if I do that, C1 interchange with C2, so then I'll get minus ABC, sorry, C1 interchange with C3, so I'll get minus ABC, and this will become 1, 1, 1 over here, and I'll get over here A, B, C, and here A square, B square, and C square. Now, I need this, so I will swap these two columns. So when we swap, the value of the determinant changes. So one which had become negative will again become positive. So I'll get here ABC now, and I'm going to interchange C2 with C3. So 1, 1, 1. This A, B, C will come over here, and A square, B square, C square will come over here. Now pay attention over here. When I did this operation is valid when we are adding or subtracting two rows. But if you see over here, I have not added or I have not subtracted any rows. I have just multiplied with some random numbers. Here A, B, C in this case. But this is not allowed mathematically. If you are multiplying, then you have to divide by something so that the value of the determinant does not change. Okay. So when I'm multiplying with A, I will have to divide it with A also. When I'm multiplying with B, I will have to divide with B also. When I'm multiplying with C, I will have to divide with C also. This will be, so the value of this determinant which I had taken over here has become 1, 1, 1, A, B, C, A square, B square, C square. This determinant can be written something like this. So if I write over here, so I'll get, therefore determinant is equal to 1, 1, 1. This is A, B, and C. This is A square, B square, and C square. Just a minute. This minus sign, and instead of this, I can write this. Are you guys able to see the screen now? Okay. So value of this determinant, we have just proved that it is this 1, 1, 1, A, B, C, A square, B square, C square, which is exactly same. This and this is exactly same. So when you subtract two similar quantities, you will get 0. So the value of this given determinant is 0. Okay, the value of this determinant is 0. So hope everyone has understood. If you have not understood, you can ask me. Okay, please take this screenshot of this. This was also a little bit of unique numerical. Whatever I'm taking are will be previous year's exam questions, or it will be some important questions only. Everyone has taken the screenshot. Okay. I hope everyone has taken the screenshot. Let's try next numerical. Given that x is equals to minus 9 is the root of, given that x is equals to minus 9 is root of this determinant x 3 7 2 x 2 7 6 x equals to 0, then other two roots are option A 2 comma 6, option B 2 comma 7, option C 6 comma 7, option D 2 comma 3. You guys can try this. I'm just giving you some time. Try this and let me know. Try this numerically because it seems very simple. The numbers are also small. Okay, you can try directly also because one root is already given, that x minus 9 as a root. Then the other two roots are. So, but obviously when you are going to solve this determinant, you may get a quadratic or a cubic equation. Try it and let me know which is the answer, option A or option B, option C or option D. Try it. It is a simple numerical. We have done a lot of complex numericals today. You guys can try this simple one. Try this and let me know what you are getting. Solve and let me know the answer. Got any option, any answers? A, B, C, D. This was a very simple one. That is why I just gave you to give it a try. Any answers? 2, 7. Very good. Okay, it is 2, 7. It was simple. If you solve, you will get a cubic equation and one root is already given. If you don't know how to solve, then we can also try with this determinant one also. If I add, I'll get x plus 9 also here also. So what I can do is I can do this also. I can do R1. In R1, I can add the rows R2 and R3. So I'll get x plus 2 plus 7, so that is x plus 9. Here also 3 plus x plus 6. So here also I can get x plus 9. Here also 7 plus 2 plus x. So here also I can get x plus 9. 2, 7, x, 6, 2 and x. And then I can take x plus 9 as common. Now what will remain inside is 1, 1, 1, 2x, 2, 7, 6x. Now if you want, you can further try to reduce it, or you can directly take the determinant. So I am going to directly take the determinant. So x into x, that is x square minus 12 minus 1 on here 2 into x, so that will be 2x minus 14 plus 1 into 6 into 2, that is 12 minus 7x is given equals to 0. So I'll write equals to 0. I can write x plus 9 equals to 0, or this term what we are going to get over here is x square minus 12 minus 2x minus minus will become plus 14 plus 12 minus 7x equals to 0. So I'll get x square 2x and 7x, and here I'm getting 14 plus 12 minus 12 is getting cancelled. So x square minus 2x minus 7x plus 14 equals to 0. So from here I can take x as common. So here it will remain x minus 2. I can take here 7 as common. So here also I'll get x minus 2. I'll get x minus 2 into x minus 7 equals to 0. So I'll get x is equals to 2 or x is equals to 7. So the other two roots are option number B, 2 and 7. Okay, very good. This was a simple numerical. Let's try next. Let P lambda raised to 4 plus Q lambda raised to 3 plus R lambda square plus S lambda plus P is equals to determinant of lambda square plus 3 lambda, lambda minus 1, lambda plus 3, lambda plus 1, lambda minus 3, minus 2 lambda, lambda minus 3, this is lambda plus 4. This is lambda minus 4 and this is 3 lambda. Let P lambda raised to 4 plus Q lambda cube plus R lambda square plus S lambda plus P equals to the determinant be an identity in lambda. be an identity in lambda. P, Q, R, S, T are constant. P, Q, R, S, and T all are constants. Then the value of T is, we will have to find out the value of T. 1, 2, 0, and none of this. So do you know what is an identity? What is an identity and what is the difference between an equation? An equation will only have certain values which are satisfying those equations. But when I say it is an identity, each and every value of that will satisfy that equation. Say for example, I am saying sin square x plus cos square x is equal to 1. So you take any values of x within the given domain, okay, then all the values in the given domain will satisfy that, okay, equation, that is sin square x plus cos square x is equal to 1. Any value of x is going to satisfy the value, then it will be called as identity. So here he is saying that the value of this determinant, okay, this kind of a pattern, the value of this determinant can be given by this, okay, p lambda raised to 4 q lambda cube plus r lambda square plus s lambda plus t, and it is identity in lambda, like sin square x plus cos square x is equal to 1 is identity in x. Similarly, this is identity in lambda. Then what should be the value of t? Okay, now what should be the value of t? So now lambda, if I want to find out the value of t, the best way is to put lambda is equal to 0. So here only t will remain, all other terms will become 0, so that it will become easy for us to find out the value of, okay, t. And why I can take value of lambda is 0, I can take any other values of lambda also. Not only 0, I can take any values of lambda which belongs to real number. Why? Because he is saying that it is identity. Okay, so any values within the given domain can be taken. And therefore, to just make my life easy, I am going to take value of lambda as 0. So put lambda is equal to 0. So this all terms will become 0, and what only remains over here is p is equal to. So this will also become 0. 0 minus 1, that is minus 1. Then 0 plus 3, that is 3. And 0 plus 1, that is 1. This will also become 0. 0 minus 4, that is minus 4. 0 minus 3, that will be minus 3. 0 plus 4, that will be 4, and this will also be 0. So let's find out the value of this determinant. So whatever value of determinant I get, that will become my value of t. Okay, so 0 into anything is 0, so this is 0. Then minus will become plus, so plus 1 and 2, 0 into 1, that is 0. Minus 3 into 4, so minus, so that will be minus 12. Plus 3 into 4 into 1, that is 4. 3 into 0 is 0. So I'll get t is equals to minus 12 plus 3 into 4, that is 12. So plus 12 minus 12, 0. So I get the value of t as 0. So what is the answer? So answer is option number C. Okay, this was a unique numerical. The solution is very easy, but it requires little bit of understanding. Okay. Everyone understood? Please take the screenshot. Okay, everyone has taken the screenshot. Let's try next numerical. Let A, B and C be real numbers with with A square plus B square plus C square is equals to 1. Then the equation of this determinant ax minus by minus c bx plus ay cx plus a bx plus ay minus ax plus by minus c cy plus b cx plus a cy plus b minus ax minus by plus c equals to 0. If a, b and c are real numbers and if a square plus b square plus c square is equals to 1, then this equation, okay, this determinant equals to 0. This equation represents, then the determinant of this represents parabola and ellipse pair of lines or equation of a straight line. So the determinant is given as in this form and we need to solve this determinant, and after the solving determinant we should get either of this. This value of determinant should represent either the value equation of a parabola or an ellipse or pair of lines or straight lines. Okay, both are different. Straight lines will be a linear equation, whereas pair of lines will be again a quadratic equation. A homogeneous quadratic equation, or it can also be non-homogeneous quadratic equation. Okay, you guys can give it a try. It really seems a mind cracking one because all the terms are okay. You can see a lot of complex terms are there. We cannot take the determinant. We'll have to do some operations, either row operations or column operations. We'll have to bring it in simple terms and then only we'll have to take the determinant to get the answer. Okay, and do not forget this is also given to us. So this condition will be helpful somewhere. 101% this condition is going to be helpful somewhere. So we should also think about somewhere getting this kind of term also. A square plus b square plus c square is equals to 1. So that our life becomes easy. So just try to think in this terms and just give it a try for 2 minutes before I start solving. Just give it a try. Are you guys trying it? Just try, you will have to apply a little bit of head over here, you will have to crack little bit of head. Try it a bit. Think in that direction, a square plus b square plus c square is equals to 1. That condition will be really helpful for us. Because when we solve the determinant, we will get this term. But if we just remember the general equations of parabola or ellipse or straight lines, we don't have the terms a square, b square, c square. We have the terms a, b and c. So when we find out the final determinant, we should not get a square, b square, c square, and that is why he has given us over there. So multiply first q by a, then I get a square. There also I get a square, and then also I get a square. And then a square I'll get EDX over here, and there I'll get ACX. And then I can multiply with a square. It's minus ABY minus AC, and this will become ABX plus A square Y, and this will become ACX and A square. And then if I multiply it with B, so then this will become B square, and this will become B, this will become C square, and this will become C. And then if I try to cut, nothing is getting cancelled. Then here I get ABX, ABX plus AY minus ABX plus B square Y minus B. ABX will get cancelled. Here I get A square Y. Okay, so what we are going to do is, we will multiply this first column with A. Okay, I am going to multiply this first column with A. So multiply and divide with A. So I multiply this with A. So I'll get A square X minus ABY minus AC. Here I'll get ABX plus A square Y, and here ACX plus A square. Okay, I've multiplied first column with A, so I'll have to multiply and divide with A, right? And this I'm keeping as it is, BX plus AY minus AX plus BY minus C, CY plus B, and CX plus A, CY plus B, minus AX minus BY plus C. Now, what I'm going to do is, I'll multiply this with b, so I'll get b squares over here. I'll multiply this with c, so I'll get c square term, so that I can get this term, and I'll subtract it from here, so that I get a simplified version over here. So I will do now r1 minus, okay, b r2 minus c r3. So I'm doing transformation only in first row. Okay, I'm not doing any transformation and column. C1, C2, C3. I'm doing transformation only in column 1, so column 2 and column 3 as it is. That will be bx plus ay minus ax plus by minus c, cy plus b, and over here cx plus a, cy plus b, and over here minus ax minus by plus c. So here when I do, okay, BC2, okay, C1 minus, so I'll get this A square x minus ABY minus AC minus BC2, so I'll get over here B square x minus ABY, and here minus C square x minus AC. Instead I'll add, so at least I'll be able to cut something. So if I add, so this will become plus 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 plus. So minus AC plus AC will get cancelled, minus ABY plus ABY will get cancelled, and A square x, B square x, and C square x. So that will become A square plus B square plus C square, the whole into x. Now you are able to see the board. Okay. Similarly, so I am going to add, I will not subtract, because if I am subtracting, I am not able to cancel it out. When I am adding, I am able to cancel it out. Similarly, when I do here, I have this term abx plus a square y, plus this will become minus abx plus b square y minus bc, and this I am multiplying this column with c, so this will give me plus c square y plus bc. So here plus abx minus abx will get cancelled, and then plus bc minus bc will get cancelled, and y, so what remains is a square y, b square y plus c square y. So again I can take over here as a square plus b square plus c square common y. Same thing for third also, a square plus b square plus c square, and here anything common will remain. So I'll get this ACX plus a square plus bcy plus b square minus ACX minus bcy plus c square. So plus ACX minus ACX will get cancelled, plus by minus by will get cancelled, so I'll just get a square plus b square plus c square. Okay, I hope everyone has understood this. This is little bit of complex one. So now we know that a square plus b square plus c square is 1, so this entire thing will become 1. So now I will get over here as x, here I'll get y, and here I'll get 1. And here bx plus ay, cx plus a, here ax plus by minus c, here I have by plus b, here also I have cy plus b, and here I have minus ax minus by plus c. Now again we will have to think of how we can simplify. So here if I multiply it with b and then I subtract it, so bx will get cancelled. So here when I get multiply the advantage, here also by here also will get cancelled, and here also bb will get cancelled. If I multiply this with c and then I subtract cx will get cancelled. Here also I will get advantage. Cy will get cancelled, and here also I will get advantage. Plus c minus c will get cancelled. So next what I am going to do is C2 minus BC1 and C3 minus CC1. Okay, so the transformations are occurring in column number 2 and column number 3. Column number 1 as it is x, y and 1. So when I do this, bx will get cancelled, so what will remain is ay. C2 minus BC1, so minus ax plus by minus c minus by, so by will get cancelled. What will remain is minus ax minus c. Here I am multiplying it with b and subtracting bb will get cancelled. What will remain is cy. Similarly here cx plus a minus cx, so only what will remain is a. Then cy plus b minus cy, so only what will remain is b. Here minus ax minus by plus c minus c, so what will remain is minus ax minus by. So now I've got the things in a simple term. I think so now we can take the determinant. I guess we'll not be able to simplify it further. Okay, I don't think so it is possible to simplify further. So we'll take the determinant now. Let us take the determinant now. So x into minus sign minus ax minus c into minus ax minus by minus bcy minus ay into, so y into this, y into minus ax minus by minus b plus a into, so this will give me c into y, so that will become cy square minus, so minus minus will become plus ax plus c. Okay, cy square minus minus will become plus ax plus c. So from here also I am taking minus sign common, here also I am taking minus sign common, so minus sign minus will get cut. So x into ax plus c into ax plus b minus bcy minus ay into, so here I will get minus axy minus by square minus b, and here I get a into cy square plus ax plus c. So let's solve. So x into ax into ax, so that is going to give me a square x square plus ax into b, so that is going to give me abx plus this is going to give me acx, so this is going to give me plus bc minus bcy. Getting complex, minus ay, So this minus entire this minus sign I am taking outside, so this will become plus axy plus by square plus b. And here a into by square plus ax plus c. So now if I multiply x inside, so I'll get a square x cube plus abx square plus acx square plus bcx minus abcy, sorry, minus bcxy. Now if I multiply this ay inside, so I'll get a square xy square plus aby cube plus aby plus acy square plus a square x plus ac. So nothing seems to get cancelled out over here. From somewhere can we take anything common? That we will have to see. Here I have y square and y square term. Here I have x square and x square term. If I take x square common, ad plus ac, that is not going to give me anything. A square plus b square plus c square. So I am not getting any b square term also, I am not getting any c square term also. So I think we will have to try and further, we will have to solve this, I guess. Just give it a try. Just think now what we can do. We'll have to solve something over here because it is becoming very complex. Nothing is getting cancelled out. If nothing is getting cancelled, such a big equation is there. Okay, will not be able to say anything about if it is any straight line or a circle or anything. We'll have to think further. We cannot leave it over here. Okay, we just saw we are not getting anything. Let us think now. I'm sorry, I forget 1 by a was over there, no? In the beginning, we had multiplied and divided with a. We had this 1 by a term also. What? Still, we are not going to get. Just think and tell me what can we do further after this. Okay, any thoughts on what we can do? We are not getting anything over here. So I will have to rub this out. I thought after taking determinant from this point, we may get some answer. But I was wrong. We'll have to solve further. So this terms will have to reduce further. We'll have to think of all these terms also again. Okay, so I'm multiplying this row with x. So if I multiply and divide, so I'll write 1 upon ax is x square axy axy minus ax minus c b 1 cy minus ax minus by. So if I multiply this with y and if I add with this, if I multiply this with y and if I add, then I'll get by minus ax minus by. So by will get cancelled at the same time. If I add this also over here, so I'll get ax. So ax will also get cancelled. By will also get cancelled. So I'll get 0 over here. So now what I'm going to do is, so I'm going to do R2 y into R2 plus R1 plus R3. So let us perform this operation, or I can write it as something like this: R1 plus y into R2. So when I'm multiplying and then I'm adding, it will become ax plus by minus ax minus by. Okay, so I'm going to do R1 plus y R2 plus R3. Okay, so 1 upon ax. So whatever transformations I'm doing transformations in row 1, so row 2 and row 3 as it is, y minus ax minus c, b here 1, cy minus ax minus by. Okay, so now when I'm going to do here, this will become x square plus y square plus 1. So here I'm going to get x square plus y square plus 1. Here I'll get axy. Here I'm multiplying it by y. So minus axy minus cy, and this also cy. So plus cy minus cy is getting cancelled. Plus axy minus axy is getting cancelled. So this will also become 0. And this is also becoming 0. Okay, so I guess now it's enough. Now we can try, I guess, because this is 0. Okay, so now we can give it a try. So now solve it and let me know what answer we are getting. I think so now we are going to get it. I don't think so we can further simplify it. X square plus y square plus 1 into this. So this minus sign minus ax minus c into minus ax minus by minus bcy, okay, equals to 0. This is what he has given the equation. So 1 upon ax into x square plus y square plus 1 into this minus sign from here, minus sign from here will get cancelled out. So there inside I'll get ax plus c into ax plus by minus bcy equals to 0. So this a into x will go over there. So that way anyway is going to become 0. There's also 0 upon this will anyways is going to become 0. So what will remain over here is I'll multiply this, so I'll get a square x square plus ab xy plus here c into this acx and here plus bcy minus bc equals to 0. Okay, this entire term I've taken 0 upon this x square plus y square plus 1 and this ax into 0, that is going to give me 0. So now plus bcy and minus bcy gets cancelled. So I am getting a square x square plus ab xy plus acx equals to 0. Now a and x is there everywhere, so I can take a and x is common. So what will remain here is ax plus what will remain here is by plus what will remain here is c equals to 0. So 0 upon anything is 0. So finally I will get ax plus by plus c is equals to 0. So this is the equation of what? It is the equation of the straight line. So the given thing is nothing but a straight line. In the beginning I said by seeing the numerical itself I was sure this looks a very complex. Everyone understood this numerical. This was really okay, one which makes you think. Everyone has understood the solution. Please take the screenshot of this. So finally we have got that this given determinant equation represents nothing but a straight line. Okay, anyways, the time is also done. We'll meet, I think so, I guess we'll meet offline the next week, I guess. Okay, have a nice day ahead.